All right, picking up where we left off on Tuesday. Here's example 3. We're graphing the equation graph f of x equals 4 times 2 to the x. Compare the graph of the graph to the parent function and describe the domain and range of f. All right, so let's start with, what does the parent function mean? When we're talking about parent function, we're talking about like the base exponential function. So we'd be comparing that to, we'll call this g of x equals 2 to the x, right? Because we're multiplying, this is my parent function, and my function that we want to compare it to is, we're multiplying everything by 2. So if we create a table here, let's go ahead and make a table. We'll do this. We'll do like 3 points. We'll do 0, 1, 2, and 3. All right, so this is going to be x. Then we'll do my parent function, g of x, and then the function we want. So as we plug in x to this equation, we're going to write my response here. Same thing here. As I plug in x there, we're going to take that f of x and put it in here. So if we're going to take 2 and raise that to the 0 power, that's just going to be 1. And we raise 2 to the first power, that's going to be 2. And remember, 2 squared just means I do 2 times 2, which is 4. And 2 to the third power would be 2 times 2 times 2, which would be 8. All right, so this would be our parent function. And we can graph those points. All right, so what we're going to do now is we're going to take that, we're going to plug in each of these x's into our new function, right? So if I want to find f of 0, I'm going to write 4 to the 0 power, right? 2 to the 0 power, we already said was 1, so we're going to have 4 times 1, which would end up being just 4. So this number right here is 4. And now we want to find out when x is 1. So what I'm going to do is I'm going to plug this in. So 4 times 2 to the first power, which would be 4 times 2, which is 8. And then f to the, when x is 2, let's rewrite that, make that a little cleaner. When x is 2, I'm going to plug in 2 whenever we see an x. So 2 squared we said was 4, so 4 times 4 would be 16. Same thing here. F of 3, 4 times 2 to the third power, that would be 4 times 8, which is 32. So you can start to see that, hey, the difference between my g of x and f of x is going to be, we're multiplying it by 4. Okay, so if I had to graph this, let's go ahead and graph this now. Wrong button, there we go. Okay, so we're going to go ahead and remember, when we're talking about this equation, right, remember this tells me my starting point. So we're going up to, no, sorry, that doesn't tell, that's how much we're multiplying every single time. So my parent function is going to start at 1, and when x is 1, my height now is 2, and when x is 2, my height would be 4. And we're going to need a function that looks something like this, and this is going to be my f of x. Okay, so now we want to graph our new one, and we'll do this in blue. All right, so when x is 0, my height now is 4. Let's do this in red, actually, make this a little nicer to read. And then when x is 1, we have to go up even higher. So we're going to extend this out a little more. We're going to go up 5, 6, 7, 8. And our point would be here. So my graph could look something like this. So that's how you'd sketch it by hand, but you can always use Desmos here to take a look at it. So let's go ahead and take a look. Let's write this. We have y equals 2 to the x. And then we also have, let's do y equals 4 times 2 to the x. All right. So notice how when we multiply by 4 here, let me highlight this in on the pad, we're increasing much faster, right? That's also going to tell us where our starting point is higher. My y-intercept, if I can get this to work with me here. Let's go this. My y-intercept for the blue line is much higher at 4 versus 1 for the red line. And we're increasing faster because we're increasing at the same amount, sorry, not faster, but the same rate because we're doubling every time. So if we go up to, when x is 1, we're at 8. But we went from 1 to 2, so we're doubling. Okay. All right, so remember what domain and range is. Domain is going to tell me all the x values, and our range is going to be all our y values. So if I had to describe the domain for this problem, we would write all real numbers for my domain, or you could write it like this, where you can go negative infinity to infinity. Because if I zoom out, it's going to keep going on forever. Yeah, it might take a while to see a number there, but it's going to keep going forever. And my range is going to be, we have a stop at 0. It doesn't matter how close we get to it. I can zoom in closer and closer and closer. You're going to notice I'm never going to cross that y-intercept. So my range is going to be all numbers. My y is going to be everything that is bigger than 0. So from 0 to infinity. Because again, right, if we zoom in, we're never going to touch our line. This is called an asymptote. You can see here. It's a little easier to see if I start a little further out. I can keep going. Neither one of these functions is ever going to touch. So here are our two. Here's our domain and range. All right, so there's first two examples. First example. My next example is now we want to graph this one. So again, remember my parent function is still going to be, it's not going to be 2 now, so we need to change this one to 1/2. So I'm going to go ahead and put parentheses, 1 divided by 2, and then close the parentheses. If it wants to work with me here, there we go, close the parentheses. So we're doing 1/2 to the x, and we're also going to have y equals negative 1/2 raised to the x. That forgot the divide. Let's fix this up just a little bit. All right, so here are our two graphs, right? We can also plug those in if we want to. You notice it can be slightly different shape. So we're going to describe the domain of our original equation, right? So our original equation is going to be the green one. And notice how because there's a negative sign out in front, we have that negative sign out in front, it's going to flip this along that y-axis. So we have a negative sign, it's not going to be going up or down, it's going to be flipped. So my domain here is still all real numbers. And then my range is going to be, we want all the values that are less than 0. So my top number is going to be 0. And we can go forever in the negative infinity direction. So we're doing all numbers that are less than 0. Okay. All right. Well, there's our two examples for today. You have work in Delta Math. Go ahead and get started on that.